I know this table, so I can manipulate, I can control my data. If I go to the FHIR, yeah, I have FHIR search, but it's not enough, yeah, to do some stuff. So, so that's the problem we're trying to address. So, make a bridge between the FHIR data and database ecosystems, yes. And the challenge one was that the FHIR is based on domain aggregate. It's a concept from domain-driven design. Yeah, so essentially it's a JSON document. It's a nested data structure. Yeah, and most of traditional databases are flat tables, and they are optimized to be flat tables. And the tooling around is expecting the flat tables. And the challenge, and the first challenge was how we can use the power of SQL and existing databases and put the FHIR inside. So the naive approach, like generate all the tables for all FHIR elements, that just doesn't work. You will get 1,000 of tables, and it's hard to work with it. And this is a very old known problem, which is called object relational impedance mismatch. Yeah, you probably heard about this. But we haven't talked about just objects, yes, but about the documents. And then people want to use both. And the technology potentially allows this. So the modern databases and traditional databases, we see the support for JSON or binary JSON. So for example, in ANSI SQL standards 2016, we have JSON path support, and some databases like Postgres, Oracle, even MS SQL partially implemented this stuff. So potentially you may work with the FHIR data right in your database. Yes, as well, there's a great progress with the columnar databases after the Dremel paper. Who know Dremel paper? Okay, so we know how to store nested data structures in columnar storages and do kind of population level analytic on it. Yes, and we have like BigQuery, which has implemented this, and very nice open source Apache Parquet format. And there's a lot of query engines which can run on top of Parquet. There is a lot of stuff going on with the Spark SQL, Databricks, Data Lake, you heard about this. So this is very nice because it can connect like ML pipelines and other stuff like Python stuff with the data. And there's a nice new databases like ClickHouse, DuckDB. If you never heard about this, is open source columnar databases. Yeah, just go and see what they can do. And yeah, that was the first challenge for the advanced engineer to put FHIR inside these databases and make it work. And that's what we tried to do. Yeah. So for example, we published in 2014 the Firebase. It's open source project, how to store data in Postgres in binary JSON. Then we released 8box FHIR platform, which was built on top of these ideas from database. Then Ryan Brush created this Bunten project, where he tried to use Spark SQL and query the FHIR data. At the same time, the Patrick Sandberg in Google, at the time Ryan was in Cerner, so Patrick started loading data into BigQuery. Yeah, and we tried to get together in 19th and discuss what we have. So Ryan Brush wrote the first draft. It was mostly for analytical stuff based on the work he did. And then we disappear for some years because we start using it. Yeah, so we start using it and people started implementing it. So aggregating the knowledge, aggregating the experience, how the SQL and FHIR may live together, and optimizing. So I will just show you that it is possible with the modern databases. For example, in Postgres, you can store in a binary JSON. I'm proud to be the guy who implemented binary JSON in Postgres. This is a Russian guy, Oleg Bartunov and Fedor Sigayev. So they did it. So and the binary JSON means it's efficient. It's not string. It's not parsed every query you're doing. So and the Postgres has a bunch of functions to work with the structured data, nested data. So you see this arrow operator and the path expression, so you can access nested elements. Yeah, there is a JSON array elements. It's like a nesting array of JSONs. So potentially you may work with this, but that looks like SQL, but not SQL. Yes, a little bit cryptic. Yeah, and that's what we found. Yeah, the new ANSI SQL introduced the JSON path. You see, it's kind of similar to what we have in FHIR path. Yeah. And now it's a standard, and I think the more and more databases will support it, so you even can do something like this. So if you go to the Spark SQL, if you would be able to generate like Parquet file, then you will be able to write such type of queries with nesting and joining. So that's everything work. But you see it's completely different from what you saw in Postgres. Yeah, that's what we found. It's hard to standardize at the first time. So what we come and see the different dialects, different approaches. Some are schema-less, some are schema-based stuff. Okay, yeah. So we started working, and it really works. So there's a lot of project done with this. So this kind of SQL on FHIR dialects are used a lot in the real projects. Yeah, but we identified a few problems. Like it's too technology specific. Yes, if it's BigQuery, it is BigQuery syntax and all this stuff. If it's Spark SQL, it's completely different. So we want something portable. We want so everybody can kind of share the knowledge, share the reports, measures, and stuff like this. Yeah, and as well, as you see, it's hard for user to start thinking with these nested data structures, with all these functions and writing SQL. So that's the conclusion everybody comes. So the users still want flat views. Users still, the tooling like Tableau and Power BI still done to handle these flat representations, yes? In the future, probably this will change, yes? So then you may be able to use the true SQL on FHIR. Yeah. But then we decided to get together and discuss what we have in common. Can we unify? Can we extract some best practices? Can we make it available for other users? Yeah, so facilitate this stuff. That's how the HL7 SQL on FHIR V2 was started this year. So, and yeah, you're welcome to join. We have a dream team. It's really a dream team if you look at the names, if you know at least some of them. And I'm pretty sure that we would be able to produce something interesting. So, okay, yeah, and it's my opinion about our vision. So you can go to the Zulip chat and and ask every member of the team what he think about this. Yeah, but we come to the conclusion that we're gonna split it into 3 layers. At least 3 layers. Yeah, there probably will be more layers and more interaction between the layers. So the first, it's a storage format. How we potentially can store FHIR in the databases which support nested data structures. The second, it's a new great idea. So can we define some use case specific flat views so that the one engineer can define this flattened view, it can be standardized, and the other engineers and tool can use this flat representation. I mean, sometimes joke at the CSV mode representation of FHIR, yes? And there was suggestion to use a FHIR path to express this flat view. And then we're expecting on top of this flat view, you may write some potentially portable queries, yeah? Or you may connect existing ecosystem for BI and analytics. Yeah, so the layer 0, we call it annotational layer, I call it storage layer. So it's a, yeah, what we found that everybody at least doing some small transformation to FHIR resources. And the first seamless transformation is parsing refs. Because if you store the reference as a URI or as a string, it's hard to join, it's hard to work inside databases. So all implementation trying to parse it into resource type and ID, so you would be able to then work with this data in a database. So that's what we discussed, and the storage format expect like some kind of schema which can be shared between the implementations. Yes, and we're discussing other potential transformation like normalizing dates, so we can use native database timestamps and stuff like this. Probably good practices like hashing IDs if you're aggregating from different sources. Yeah, and there's some suggestions for contained resources and probably first-class Parquet support, because I think it's a very promising direction. Yeah, so that's the storage format. And the second layer is a definition of the flat view using FHIR path. So we clearly understand that they are going to be user specific, because you could not flatten FHIR in a general way. Yes, you got these thousands of tables. So they pretty should be kind of use case specific. So we're going to develop the framework to define these views for specific use cases. And then on top of these views, you can do the rest. Yes, so the logical is something like this. So this is not existing language. So if, for example, we want to extract the blood pressure, so here it is a mix of SQL and FHIR, and we and I would like to say thank you to FQL guys. So our initial attempt to define this flat view was a little bit more cryptic, but yeah, guys showed us that it can be done much simpler. So this is the general idea. Yes, let's take observation. Let's extract some elements, then filter the component like systolic and diastolic and extract. So we call it unnesting or joining or expanding. So, but for pragmatic reasons, so we are not inventing the new language. So no other Antler parsers, grammars for you. So we decided just write it as a JSON document. Essentially, it's going to be the FHIR resource. Yes, it says exactly the same. So let's take from observation specific elements. This for each instruction, that's where you go on where you're unnesting elements, flattening them, and yeah, we decided to support a subset of FHIR paths. Not all of them, because it's a Turing complete stuff. So just some useful subset for that. Okay. Yeah, here's what we choose for the first try. So very limited set of expressions and stuff like this. And there's the idea that potentially we can transpile this subset of FHIR paths into technology-specific SQL. Let's say JSON paths, or maybe just nested SQL stuff. And that's how we can solve both problems. So we can still store all the FHIR in a FHIR native way in the modern databases, but provide for the user very nice flat view. So here he would sorry he should not know that is it true table or is it view on top of this true table. Yeah, but there's other scenarios when, for example, you do bulk export and some engine may really materialize this view and produce your CSV file. That's, for example, the Josh demo he did, like just using JSON paths, just going through all the ND.json file resources and flattening them one by one and putting it into S3, and then you can load into, I know, it's Snowflake and run analytics. Okay, and the third layer is going to be for specific use cases. You can define your SQL queries, and if they are flattened, it's much easier to make them portable. Yes. So there's still some differences in dialects and data types in different databases, but this is the second problem we're going to solve after we will define the view. Okay, so yeah, what's next? So we are thinking that it potentially could be the FHIR resource, the view definition. Yeah, there are some ideas like we can do the view-based search or provide the portable queries on top of it. The guys from NCQA are really interested to efficiently execute SQL rules, and there's ideas to transpile SQL to SQL. Potentially the view definition may be integrated with the bulk export. So instead of exporting everything, you can ask server for some specific fields in a CSV format, and then it's going to be much easier to work with it. Yeah, so you just provide the set of views you want to export, and you're getting like CSV files in S3, again loading in Snowflake. Yeah, so it seamlessly can be integrated with existing ecosystem like Power BI, DBT, Looker, and stuff like this. And we're going to do experiment and try to map the FHIR to OMOP using these views and stuff like this. So that's going to be like our quality assurance. Yeah, okay. So, yes, so we are open working group. So the draft of the spec is in a FHIR GitHub repo, SQL on FHIR v2. So there's a lot of activity in the chat.fhir.org and Analytics on FHIR channel. Please join if you want to be informed. So, and we have a weekly calls. There's a recording of weekly calls on the YouTube, so you can listen and join us and be in context. Okay, and then we're gonna go to the demo. I will lately I will send the links so you will be able to play with this. There's two demos now available, mine and Josh. So let's go to the demo. Yeah, here's GitHub. There's a Zulip. You see there's a lot of activity and discussions. So we are doing design. So please join, ask your questions. Here's the recordings of meetings. And yeah, here we are. So and I can show you initially some simple stuff. Sorry, this is an Eden, but it's essentially JSON. So if you put the colon after the keyword, you will get the JSON, and you don't have to write all the commas. So I hope it's clear. Yeah, so maybe let's start and write some view from the beginning. So let's just remove it. Okay. So here we're selecting from patient. So this is not the part of spec, but this is just for debugging, just limiting the. And we start. So in expression, we can write an expression of element we want to get. Let's start with ID. So potentially you can provide the name. So in this implementation, if expression, if name skipped, so then expression is used. Okay, what else we want to get from the patient? Let's say birth date. Okay, so we can get the birth date. We can give it name, I don't know. And we're discussing that potentially we can provide the type. It's a database type, so that so the FHIR type, or essentially JSON type, the weekly type stuff can be coerced. So let's say date. Yeah. Okay, now go deeper and let's take, I don't know, address, city. Yeah, so we got the city. So in this demo you can save it, let's say. You can save it and you can materialize. It will create the Postgres view for that stuff. And then you can go to the queries. And query it. So that's how it's expected to work. Yeah. So in a demo, there's a bunch of samples. Yeah, like there's a special function get ID. So we decided to abstract it away. So potentially it may run on strings. So or if it's parsed in a database, so the only ID is returned. So yeah. What else? So something interesting. Yeah, so because we're all doing FHIR, yeah, let's take a look at the structure definition. So let's analyze the structure definition. So, for example, what most popular types of elements, yeah? Who can predict?
String.
String. The other options?
Yeah, just for a counterpoint ID. Oh, extension.
No, you're completely not right. Okay, so let's read it. So we have, yeah. So the structure definitions are loaded. So then let's take ID, kind, and derivation. That's clear. Here we're doing unnesting. So for each element there will be produced the row, and it will be joined with the rest of columns we defined. So we're taking path, we're taking type, min, max, and probably bindings. So we can run this view right here. So we will get this flat table, yeah, for all this stuff. And then we can jump, for example, into Metabase. It's an open source BI tool. So, and then we can go through the summarization. I'm showing how the existing tools may work with this flattened stuff. So I would say, show me, okay, the last try. Let me move this. There's some intrigue. Okay. And the second is a reference, the string only third. Yeah. The empty stuff is, yeah, I think because profiling and backbone element is only here. Yeah, so. And I even build the dashboard in a few minutes. Yeah. Yeah, you can definitely do the queries, all of these elements, and then just plain SQL. And here I did the dashboard. Yeah, this is the most popular data types. Then I split the path and took the element name, and this is the most popular name of the element. So we can see the count. It's like 232 types. And then codes, identifier, and statuses. Yeah, as well, here's the stats for cardinality. Yeah, so you see that we mostly have like cardinality 1, a few arrays, and there's some others. Okay, and that's amazing. Yeah, that's quite funny to play with these tools. If you have a plain table, yeah, this is a modern tools can even suggest you and make some summarization and stuff like this. Yeah. Here's for example, for our engineer built it for Cynthia data. It's just a toy what to play, how it may be integrated with but it was quickly built up, essentially drag and drop interface. Yeah, that's what users expect. That's what we try to provide. Yeah, and there's slightly more interesting stuff. It was built with a Power BI on the real data, I think. It's a 6 million of passion and a Postgres in a Hetzner machine, and yeah, the Power BI is nice. So, okay, that's what we want to achieve. Okay, here is a Josh demo. So I will publish the link. Yeah, so you can write the same view definition and run. It's materialized, so it's just a JavaScript, which is walking through the resources and flattening it. Okay. What else I have? Yeah, that's all. And I will publish my demo so you will be able to play. Let's get back to presentation. Yeah, what next? Yeah, so join our working group, or at least track what we are doing. So the main place, I think, it's Zulip. So Zulip Analytics on FHIR. And if you're ready, join our weekly calls if you have some ideas. Yeah, so we're doing every Friday. Yeah, and I think that's all. So I'm ready to answer your questions. Thank you.
Hello, thank you for your presentation. I had two questions. The first is, I'm surprised not to see Enter Systems in the group because they have something called SQL Builder, which looks similar.
I've heard, but I haven't seen any inter-system guys in our community. But yeah, probably they do. Yeah, there's a lot of companies. I just mentioned some. I know.
And the other, is it just for reading, or can you write inside the server? For example, for migrations of data.
Yeah, this is a good idea. Yeah, it's worth to discuss. Yeah, I remember the DevDays when guys presented dehydrated fire, something like this. That may be integrated with these ideas. Yes, if you want to write the blood pressure, and if you can provide the template to generate the fire resource, potentially, yeah, it's slightly different technology, yeah, but it potentially may be integrated.
Thank you for your presentation. I'm wondering if you guys have talked about any use cases involving looking at the history of resources. For example, if I want to see how many medication requests had their status changed from like active to canceled, or like how many patients have had address changes. Do you have any?
Yeah, a couple of times. So we discussed that the history exists. We probably should provide. I think the same pattern should be applicable for the history. For this time, we decided to push it out of the scope, at least for the first steps. So, but potentially, I think the same pattern. So, if you create the history table, you can flatten it the same way and do similar stuff. Yeah.
Yeah, so Firely has this Firely query language, I guess it's called
FQL,
FQL.
yeah.
It looks kind of similar, but it's not a JSON object, but basically all the tags are the same. Is there any relationship?
Yeah, they looks very similar. The FQL, I think, is more expressive, so you can do more stuff than you can do with a view definition. So, and I said we were influenced by FQL, so you can consider us as a subset. Or potentially, if FQL now run in the memory, if they decide to be efficient, they probably will come up to the same restrictions, and then the FQL and the view definition going to be the same stuff, so you can consider this like IST for FQL, yeah. Yeah, as well, so I forgot to say that for the first time we restricted reference resolution, so now we're thinking about that you can define the flat view only for one resource type and do all the joins outside when you flatten the table. Yeah, but some implementation like puzzlings guys provide ability to resolve resource and unnested. But we were keeping in mind the scenario when you have a bulk export, you have ND-JSON files, and you want to run some transformation on it. That definitely they could not do joins. Yes, that's why we for this time we restricted the ability to resolve in the FHIR path links.
No other questions? Okay, let's see. I don't think we have any on the Hoover app, so then we can finish the presentation. Thanks again.
Okay, thank you guys.